Alright, so section 12.3 is continuing the topic of trigonometry, and we'll talk about how to find certain angles or certain trig functions of angles on a coordinate plane, and then we'll talk about something called a reference angle, which is important for being able to find trigonometry functions of angles that are not in the first quadrant, so they're not between 0 and 90. So let's talk about that. So first of all, trig functions of general angles. Let me just redraw this picture here. Like so. So let's say you have this coordinate axis right here, and I'm just going to draw a circle all the way around the axis. And let's say we have some unknown point right here that we'll call x comma y. Okay, I don't know what that point is. I know that it has an x coordinate and a y coordinate. Now suppose that I drew a line just like that, and then I kind of dropped a line right there, so you get a right triangle. If you think about it, this distance right here, well, we're starting right here at 0, 0, and this point right here has the same x value as that point. So for example, if that point were 3, we would be going from 0 to 3, which means this distance would be a distance of 3. Okay, we're not going from 0 to 3, we're going from 0 to x. So that means this horizontal distance right here would be equal to x. And then by the same reasoning, this right here, this y value is equal to 0 because I haven't gone up or down. And then up here I'm going up to y. So if I'm going to 0 to y, that must mean it has a distance of y. Okay, then what is this red line right here, the hypotenuse of the triangle? That's also the radius of that circle. You kind of zoom out your view, that entire circle right there has a radius, and the radius is what you see right there for r. Okay, so where are we going with this? Well, we can now express the trig functions in terms of this coordinate plane, or in terms of this axis. So let's suppose this was our angle right here, that's our theta. Suppose that I wanted to write the sine of theta. Well, we may remember from earlier that sine is equal to, here's the acronym SOHCAHTOA, sine is equal to the opposite side over the hypotenuse. If you look at theta, this is opposite, and the r is hypotenuse. So I could say that sine is equal to y over r. Okay, same reasoning if I were asked to express the cosine of this angle. Cosine is adjacent, which means that x side over hypotenuse, which is that r, that radius. So the cosine is equal to x over r. And tangent is opposite over adjacent, so opposite is y, and adjacent is x. So that would be y over x. And you might recognize y over x, the change in y over the change in x. That's another way of saying the slope. So tangent is actually the slope, basically, of the hypotenuse. The steeper the slope, the greater the tangent. So that's what this chart means right here. This chart basically says if we kind of draw a circle on an angle, and in case you want to see the circle, here's where it would look right there. And we draw this radius right here, we can express this angle right here, or any angle, in terms of these coordinates. If you're not in the first quadrant, like in this picture right here, you can see this angle's in the third quadrant. If you're not in the third quadrant, those same formulas still apply. The only difference is down here in the third quadrant, tangent is, or sorry, the y value is going to be negative, so that means tangent will be negative, and sine will also be negative because it's in a quadrant where y is negative. All right, so let's actually do some of these problems now. So it says the terminal side is where the angle comes to an end. The terminal side of theta in standard position contains the point -3, -4, and you can see that right there. Find the exact values of the 6 trig functions. So if we look back at this table right here, the exact values are given to us. Let me just recopy this. So the sine of theta is this, cosine of theta is this, and the tangent of theta is equal to this. And then if we want to find the other three are just reciprocals of that. So the reciprocal of sine would be cosecant, the reciprocal of cosine will be secant, and the reciprocal of tangent is cotangent. So let's just find these first three, sine, cosine, tangent. It would be easy to find the other ones. Okay, so now if we look at this coordinate right here, really all we have to do is plug it in. This distance right here from 0 to -3 would be 3. This distance right here is 4. But keep in mind we're in the third quadrant, so that means both x and y are negative. And I'll actually tell you there's an acronym to help you remember when each of these will be negative. And the acronym is ASTC, which stands for this. It stands for All Students Take Calculus, which is obviously not actually true. It's just an acronym that means the following. It means in quadrant 1, in the all quadrant, everything is positive. Tangent, cosine, and sine are positive because y, x are both positive in the first quadrant. Okay, in this quadrant, only sine and its reciprocal cosecant are positive. And why is that? Because sine is y over the radius. And in this second quadrant, this is quadrant 2 right here. In this second quadrant, you can see that you're above the x-axis, which means y is positive. Down here in the third quadrant, only tangent and its reciprocal cotangent are positive. And why is that? Because tangent is y over x, and in the third quadrant, both y and x are negative. You can see that based on that point. So a negative over a negative is going to give you a positive tangent. And then finally, in the fourth quadrant, cosine and its reciprocal secant are the ones that are positive. Because in this fourth quadrant, only the x values are positive, and cosine is x over the radius. Alright, so let's calculate these, and really all we need to do once we have this picture is plug them in. So sine is y over r, our y value is negative 4, and the r is the radius right here, and the radius could be 3 squared plus 4 squared, which equals 5 squared. So the radius would be 4. All we did was use the Pythagorean theorem for that. 3 squared plus 4 squared. This is going to equal 9 plus 16, which is 25. If you square root both sides, you would get a radius of 5. So the sine will be negative 4 over 5. Let's check to see if that's reasonable. In the third quadrant, we said only tangent is positive, and that makes sense that sine would be negative in that quadrant. Cosine is x over r, so here's the x coordinate, and the r again is 5. So negative 3 over 5, that's a negative, and it should be because, again, we're in quadrant 3. But this tangent should be positive, so y is equal to negative 4, and x is equal to negative 3. Negative 4 over negative 3 is positive 4 over 3. That checks out because tangent is supposed to be positive in that quadrant because the y and the x are negative, and when you divide negative by another negative, you get a positive. Okay, now these three are easy once we have these. So the sine is negative 4 over 5. That means the cosecant is negative 5 over 4. We just flip it. If cosine is negative 3 over 5, that means this is negative 5 over 3 secant. And if tan is 4 over 3, that means cotan is 3 over 4. So that's it. Alright, there are 4 angles that are called quadrantal angles. And quadrantal angles are angles that intersect one of the quadrants. So let me just draw a bigger picture here. So the 4 quadrants right here, this angle is before you've even started opening the parabola, and that's, or not the parabola, but before you even start opening the angle, that's 0 degrees, or in terms of radians, it would be 0 radians. You haven't even opened the angle. Okay, now let's say, let me do a different color here so we can see this. Okay, so let's say this is your angle. Now you open the angle and it goes up here. So what angle is that? That would be a 90-degree angle. Or if you remember from the other section, we can change degrees into radians by multiplying by pi over 180. So 90 goes into that twice. So this is the same as pi over 2 radians. Pi over 2 radians. Now suppose we take this angle and now we open it all the way around so it finishes there now. That's half a circle. This little purple thing is half a circle, and half a circle is 180, which is equivalent to pi radians. And then the final one would be, if we go, so this right here is a quarter of the circle, which is 90. This right here is half the circle. Now suppose I go all the way around, that's 3/4 of the circle, and 3/4 of the circle is 270 degrees. Or this is half pi, this is 2 halves pi. So this would be 3 halves pi. If you were to change 270 into radians, it would be 3 halves pi. And then finally, if you go all the way around to the beginning, you've obviously done 360 or 2 pi radians, which is equivalent to 0. Those are coterminal angles. All right, so knowing those quadrantal angles, let's try to find another coordinate. So this right here is telling us the terminal side is at the point 0,6 right here. So that's at a quadrantal angle. That's at 90 degrees or pi over 2 radians. So we still use our same formulas. Our sine formula from before was y over r, our cosine was x over r, and our tangent was y over x. So now let's just plug these in as we see them here. So in this case, if you look at this coordinate, obviously the x is 0, the y would be 6, and the radius right here, the radius, like this thing is kind of folded in on itself. So we don't if you were drawing a circle right here, if it's just really this straight orange line, I don't even want to draw this other part. The radius is really the same as the y-coordinate. If you were drawing a circle, here's the center of the circle, and that right there is the radius. So that's why we have a radius of 6. So let's just plug these in. Y over r would be 6 over 6, which is 1. X over r would be 0 over 6, which is 0. So that means the cosine of 90 degrees is 0, whereas the sine of 90 degrees is 1, because we're at up here at 90. And then tangent, well, if you look at that orange line, that's like an undefined slope. That's so steep you couldn't even calculate the slope. Tangent is y over x, so that's going to be 6, which is y, over x, which is 0. But you can't divide by 0. So that means the tangent of 90, if you put that in a calculator, you'd actually get an error. It's undefined, because the slope is a vertical line. The picture is a vertical line. Okay, the next thing, and this is an important topic, we want to talk about something called the reference angle. And the easiest way to describe the reference angle, this terminology is a little bit complicated, but the easiest way to describe the reference angle is it's the angle that takes you to the closest x-axis, or to the nearest x-axis. And there's 4 possibilities. You could be in any one of the 4 quadrants. I'll show you how to calculate each of those. So this is kind of a nice picture. If you're in the first quadrant, like let's say this is a 40-degree angle, the reference angle is just 40 degrees. This angle here is what takes you down to that purple x-axis I just drew. Okay, on the other hand, let's suppose you're in the second quadrant. So an example of the second quadrant angle would be 140 degrees. Okay, the closest x-axis would be this yellow one right here. This is the nearest x-axis to that 140-degree angle. And what is that angle? We know that right here, the half circle is 180, and I'm at 140. So how far do I have to go to get from 140 to 180? I have to go 40 degrees. 180 minus 140 would be 40. So this reference angle actually is the same as that one, even though they're in different quadrants. All right, let's do a third quadrant example. So suppose that you have this angle right here, and I'll just make, again for these I'm just making up numbers. I'm not saying these are the actual angles. Okay, let's suppose that angle is 220 degrees. Okay, the reference angle is going to be what takes you to the closest x-axis, so that is right up here. Here's the closest x-axis. If I'm at 220 and I want to get back to 180, I can do this right here. I can do 220 minus 180, and that again gives me a reference angle of 40. That's this little angle right here. And then finally, quadrant 4. If I am in quadrant 4, that would be like this huge angle right here. So let's say that's 320 degrees. Reference angle will be this one that takes me up to 360, because that's 360 is a full circle. What's the difference between 360 and 320? That's what this says right here. And again, that would be 40 degrees. So you can see all 4 of those examples have a reference angle of 40 degrees, even though they're in 4 different quadrants. So let's get a little bit of practice with that. Tells us to sketch these angles and then find the reference angle. So 210 degrees, well here's 0, here's 90, here's 180. So 210 is not going to go quite to 270. So there's 180, we'll go a little bit further. That's about 210. The reference angle will be this one that I'm about to put in red. It's going to be this angle that takes us back up to that axis, because that is the closest x-axis. And what's the degrees at that axis? It's 180 degrees. So I need to find how far from 210 to 180, and the answer would be 30 degrees. Basically, that's my reference angle. It's the angle that takes me back up to the closest x-axis. All right, this one is radians. It's usually easier to think in terms of degrees, so we'll change this into degrees, and that's how you do it. You do 180 over pi. So the pi's will cancel. 4 goes into 180 45 times. 45 times negative 5 is negative 225 degrees. Okay, so negative, first of all, means we're going to go the opposite direction, so clockwise. So here's 0. This right here would be negative 90. That's negative 180. So negative 225 is approximately right there. So that's negative 225. Let's figure out what that is in the positive direction, though. And the easiest way to do it would be, what's the difference between a full circle 360 and that right there? So we'll just subtract these to get our actual angle, and 135 is the positive angle. So this is a positive 135 degrees. And then the question is, what's the reference angle? That's the angle that takes us from right here down to the x-axis, which occurs at 180 right here. And the difference between 180 and 135, 180 minus 35, is equal to that right there. It's equal to 45 degrees, so that's our reference angle. All right, let's do one more. We'll do 2 pi over 3. So again, if we change this into, if we change that to degrees, 3 goes into that. 60 times 2 is 120. So 120 is going to put us in the second quadrant. Here's 90, here's 120. And what's the angle here that takes us down to 180? It would be 180 minus 120, which is 60-degree reference angle. All right, so this right here, this is a big picture using that acronym I said before, which is all students take calculus. And this chart is a more complicated way of saying that. So you can see in the all quadrant, in quadrant 1, everything is positive. In quadrant 2, the students, the S stands for sine and its reciprocal cosecant. Those are the only things that are positive. The other angles are negative. In this third quadrant, all students take calculus. The take stands for tangent and its reciprocal cotangent. And then finally, in the cosine, in the calculus quadrant, stands for cosine and its reciprocal secant. And those are both positive. So we'll use that information. These, this chart right here that you see, this, rather than memorize the whole thing, I think it's easiest to memorize just these two columns right here. And I'll show you an easy way to memorize it. If you have those two memorized, you have everything else. Because you know that sine and cosecant are reciprocal. So if you know that the sine of 30 is 1/2, if you flip that around, you would have the cosecant of 30, which is 2 over 1. And likewise for cosine, if you know the cosine of 60 is 1/2, that means its reciprocal is the reciprocal of 1/2, 2 over 1. And tangent is sine divided by cosine. For example, if you divide root 2 over 2 by root 2 over 2 for sine over cosine, you would get 1, which is tangent of 45. So these angles are called special angles, and these are the three that you want to basically memorize. 30 degrees, 45 degrees, and 60, because the vast majority of problems involve one of those three. So here's an easy way to remember this. First of all, everything, and you could, all I'm doing is filling in this table on the top left, so you'll be able to compare as we do this. Everything is over 2. Every angle is over 2. And everything is the square root of something over 2. So that's not too hard to remember. The sine and cosine of anything in that chart, 30, 45, 60, is always going to be square root of something over 2. Okay, what happens here? The sines count up and the cosines count down. So here's what I mean by that. Sines count up, 1, 2, and 3. Cosines count down, 3, 2, and 1. Okay, so if you remember that the sine is, and by the way, another name for radical 1 is just 1. The square root of 1 is 1. So the sine is 1/2. Sine of 30 is 1/2. You can pretty much remember the rest of that table. The sines count up, the cosines count down. So root 1 over 2, root 2 over 2, root 3 over 2. Cosines go the other way, root 3 over 2, root 2 over 2, root 1 over 2. So we'll use that information now to do this. It says find the exact value of cos 240. Here's what we need to do. 2 steps. Find the reference angle. It's the first step in every problem. And then 2, use that 30, 45, 60 table that we just talked about. Those are our 2 steps. So cosine of 240, let's find the reference angle. Let's first draw this. So 240 is going to be, let's get a good picture here. So here's 90, here's 180. 240 puts us about there in the third quadrant. Okay, first step, find the reference angle. So the reference angle is this angle right here that takes us back up to 180. And 240 minus 180 is equal to 60 degrees. Actually, I have one more step to add here, which is all students take calculus. Forgot about that. So what are we being asked here? We're being asked, when we find the cosine of 240, that's actually the same thing as the cosine of 60. It's the exact same as the cosine of 60. Okay, because if we were to draw this triangle, remember cosine from earlier, cosine is x over r. So 60 degrees is right here. If you were to draw this circle right here, you can kind of see, it's symmetrical. You can kind of see the x coordinate right here, whatever that happens to be. It's like the exact same. This x and this x are pretty much the exact same, only this x is negative. Okay, this distance here is the same as this distance here. The only difference is because you're in the third quadrant, it's negative. So cosine of 240 is the same as cosine of 60, except it's negative. And another way to explain why it's negative is because of this acronym we said. All students take calculus. The take means that only tangent and cotangent are positive, not cosine. So because we're in the third quadrant, this number is going to be the same as cosine 60. Why? Because its reference angle for 240 is 60, but it's negative because we're in a quadrant where the x-coordinate is negative. Okay, so now we took care of the reference angle, we took care of all students take calculus, now we just need this table, cosine 60, so let's recall the pattern here. The sines count up and the cosines count down, and everything goes over 2. So everything's over 2, we're just concerned with cosine. The cosines count down, so root 3 over 2, root 2 over 2, root 1 over 2. Root 1 over 2 is the same as just 1/2. So we get cosine of 240 is negative 1/2, negative 0.5 is the exact value. And when they say exact value, 1/2 you could write as 0.5, but these ones here you can't put those in a calculator because a calculator will just give you a decimal, and we need to know the thing with the radical in it. That's the exact value. So let's do a couple more. So cosecant is, let's actually find the reciprocal of cosecant, which is sine, because if we find sine, we can easily just flip it around. So let's find the sine of pi over 6, and this one will be the reciprocal of that. Okay. First thing, let's change 5 pi over 6 into degrees. 180 over pi, those will cancel, and that becomes 30. 30 times 5 is 150 degrees. So we're being asked to find the sine of 150 degrees. Let's recall our 3 steps. Find the reference angle. Use, really these should be switched. Use all students take calculus and then use that table. So first thing, let's find the reference angle. Let's draw this, 150 degrees. Here's 90. We're not quite at 180, so 150 is about right there. This right here is the reference angle, and that's what gets us down to 180, and that is 30 degrees. Okay, so this is really the same as the sine of 30, but let's make sure that it's positive or negative. Since we're in the second quadrant, all students take calculus. Students means sine is positive, so this is unchanged in terms of its positive or negative. And our last step was to use this table. Remember that the sines count upwards, so we're going to start at, everything goes over 2. These are 30, 45, and 60 degrees, and it goes root 1 over 2, root 2 over 2, root 3 over 2. And this one is root 1 over 2. So the sine of 30 is 1 over 2. That's not what we wanted, though. We wanted the reciprocal of that. So if the sine of 30 is 1 over 2, or the sine of 150, I should say, is 1 over 2, that means the cosecant of 150. 150 is the same as that. The cosecant of 150 would be the reciprocal of 1 over 2, which is 2 over 1, or just 2. So that's how we would fill that in. All right, let's do one more. Let's do a tangent example. So 5 pi over 6 actually we just found is 150 degrees, so we can change this right away. So that's the tangent of 150. Let's do our 3 steps. We'll find the reference angle first. So the reference angle is going to put us in the, here's 90, 150 is about right here. We did this in the last problem. We know the reference angle is 30. So this is the same as a tangent of 30 with one exception. All students take calculus. The students means that only sine is positive. So that means the tangent of this angle, because it's in the second quadrant, tangent will be negative. So the negative tan of 30. So you could do this. You could memorize the table, which is back, oops, here it is, right here. You could memorize this tangent one right here. Tangent of 30, you can see up there. Or if you don't want to memorize that, you can learn it this way. Tangent is the same as sine over cosine. Okay, so really all we need to do is take here, this right here is equivalent with tangent. I still have this negative out front. I'm not going to change that. So the negative sine of 30 over the negative cosine of 30. Well, in that table, sine of 30 is 1/2. Cosine of 30 is radical 3 over 2. And then if we are dividing by a fraction, that's the same as multiplying by the reciprocal of that fraction. So these cancel. We're left with negative 1 over radical 3. And the only extra thing we want to do here is to do what's called rationalize the denominator, which means multiply by radical 3, and we'll get negative radical 3 over 3, and there's our answer. That's the exact value. Our last example is looks like some sort of roller coaster ride. It says the swing arms of the ride are 84 feet long, and you can see that labeled right here. and the height of the axis is 97 feet, so that's this part right here, 97 feet. What's the total height of the ride at the peak of the arc? Okay, so the peak of the arc, what that basically means is this. It means we want to know what this, so here's where the ride is at the bottom. At the top it's up here, so we want to know this distance right here, which means we need to know this extra distance because we can add it to 97 to get that entire yellow distance right there. So we need to know that y value right there. And they're telling us a couple of things. They're telling us that this angle here is negative 200 degrees, which is the same thing as positive 160, because 160 would complete the circle there. So that's 160. So we do the same thing. We want to find our reference angle. From 160 down to 180 would be a 20-degree reference angle. And now we have this triangle here. We have this triangle right here. Theta is 20. Okay, they're giving us opposite, which is y, and they're giving us hypotenuse, which is 84. So opposite over hypotenuse, you may remember that that's equal to sine. So we're being asked to find the sine of 20, and that's equal to y over 84. We can solve for y by multiplying both sides by 84. And then whatever this is equal to y, and then we'd have to add that to 97. So let's find out what that is. 84 times the sine of 20. Let's make sure that we're in degree mode before we do this, and we are in degree mode. So 84 times the sine of 20 degrees is equal to 28.7. So that's the y distance. The y distance is 28.7 feet, which is right here. And that means this total distance here is 97 plus 28.7. And that's going to equal 125.7 feet tall. That's how tall the ride is. So that is section 12.3. Hopefully makes a little bit of sense. We talked about reference angles and how to find the exact values of trig functions using reference angles and using the acronym All Students Take Calculus.